So hello and welcome to another video from sicmaths.co.uk, where you can find lots of free GCSE and A-level maths videos. This video is a quick roundup of everything you need to know for the Mechanics 1 module in the A-level maths Edexcel syllabus. So let's go for it. These three formulas you just need to know for the kinematics of particles video made on this website, sicmaths.co.uk, and it's just about how particles move around, i.e. shooting sideways or up or down or falling down. And V stands for your final velocity for the particle in its journey, U stands for the initial velocity, A stands for acceleration, S stands for displacement or distance travelled, and T stands for the time taken for that journey. These three are about momentum. So momentum is measured by mass of the particle times its velocity, and you can have positive or negative momentum, since velocity can be positive or negative. Momentum before equals momentum afterwards is a very popular formula you need to know for momentum type questions, because you're always having these things colliding, aren't they? So if you collect the momentum before a collision of the two particles usually, and add them together, it will equal to the momentum afterwards for those same two particles. The individual momentums might change, but the sum of the momentums will stay the same as before the collision. Anyway, impulse is basically equal to the change in momentum which can be caused by force. So there's different ways of applying this formula. So one way of saying it is Ft equals that, or you can simply say impulse equals change in momentum straight away. So F, by the way, stands for force, and T stands for time, and really that's all there is to say for that. Where T is the time the force is applied to the object so that it changes momentum. Hopefully that's made it clear enough. Anyway, F equals ma, you should know, means force equals mass times acceleration, where force is actually the resultant of all the forces on that little particle of mass m. Yeah, so all the forces that could be going different directions, and the overall force is equal to the mass times acceleration. I've stuck this friction equation with the forces because friction is just another type of force, okay, and it's calculated by the reaction force times by the coefficient of friction, which basically tells you the amount of friction between the surface the roughness, I should say, of the surface and the particle together. Okay, and basically it's trying to say how much of the pressure being applied against the surface is converted into friction. So it can be 100% of it, which means 1 of it. So if mu is 1, it means 100% of the pressure being applied on the particle to the surface is converted into friction, or none of it. Okay, when it's a perfectly smooth surface and particle. Anyway, let's move on. Where R, of course, is the reaction force. That's what the picture is all about. So anyway, let's move on. So moments are basically known as turning forces. So force times distance from the pivot point or the turning point is equal to a moment. And you usually have to calculate clockwise turning points and anti-clockwise turning points and stuff like that. G equals 9.8 meters per second. G is acceleration due to gravity. So gravity makes particles accelerate towards the center of the planet at this speed. Okay, now obviously it varies from how far you are away from the planet, but in mechanics we keep it really simple. We just say it's always 9.8 meters per second. Area under a velocity time graph is equal to the distance traveled in that velocity time graph. Okay, so that's a very simple one to learn. And what else is going on here? You got 12, example, or Formula 12. This stuff, okay, by the way, is the stuff you should be embarrassed about being taught right now, because this is so basic. You should already know this from, I don't know, just common knowledge or something, or from your GCSE days. Acceleration is a change in velocity over time, and velocity is a distance travelled over time, and area of a trapezium is basically the average of the parallel sides times by the distance between them. We often call it a height, but if you had the trapezium going sideways, it wouldn't really be the height, would it? So this is like the perpendicular distance between the parallel sides, and that is everything you need.